It was supposed to be the end of an era. In 2017, the world bid farewell to Cassini, the spacecraft that had woven through the Saturnian system like a celestial explorer, unveiling the secrets of a distant realm that had long tantalized humanity's gaze. With unparalleled precision, it had charted the intricate dance of rings, moons, and magnetic fields, transforming Saturn from a distant jewel into a tapestry of wonders. We commemorated its triumphs, revered its unyielding quest for knowledge, and witnessed its deliberate demise in the planet's embrace, a controlled inferno to preserve the pristine worlds it had studied. But what if that farewell was premature? What if, buried within the vast archives of its transmissions, lay a series of images so profound that their revelation has now halted the collective breath of the world? And what if these secret images, overlooked for years, have only emerged through the relentless scrutiny of advanced algorithms designed to pierce the veil of the ordinary? These weren't mere photographs of icy moons or swirling storms. They were revelations, encoded in pixels of frost and shadow, messages from beneath the surface that we were never intended to decipher. But now that they have surfaced, the implications cascade like a cosmic wave, too vast to ignore. In the heart of its mission, Cassini turned its gaze toward Enceladus, Saturn's enigmatic icy moon, a world of gleaming white expanses, cracked by tiger-striped fissures, from which plumes of water vapor erupted into the void. The spacecraft executed daring flybys, skimming perilously close to the surface to sample those geysers, capturing high-resolution mosaics that revealed a dynamic landscape shaped by cryogenic forces. Each pass documented the moon's south polar region, where hydrothermal activity hinted at a subsurface ocean teeming with potential. As the mission progressed, Cassini amassed a trove of images, thousands of frames chronicling subtle shifts in the ice, the spray of particles feeding Saturn's E-ring, and the faint thermal signatures of hidden vents. Toward the end, in a sequence of observations from 2009 to 2012, the spacecraft recorded a series of wide-field views of Enceladus's trailing hemisphere, images that at first glance depicted nothing more than the moon's uniform albedo, interrupted only by familiar fractures. But within these frames, concealed amid the crystalline uniformity, an anomaly manifested. A dark reddish-brown spot, roughly half a mile across, emerging like a wound on the pristine ice. To initial reviewers, it was an oddity, perhaps a transient shadow or sensor artifact filed away in the depths of data repositories without fanfare. Yet, this spot, captured across multiple orbits, held a persistence that defied dismissal, its hue and form echoing nothing in the moon's noon geology. Fast forward to the present day. In secluded computational facilities where quantum processors hum with the weight of cosmic inquiries, a sophisticated neural network, dubbed Aegis, was deployed to sift through petabytes of archival space data, hunting for patterns invisible to human perception. Trained on spectral signatures, temporal evolutions, and fractal geometries drawn from planetary sciences, the system ingested Cassini's Enceladus portfolio as a benchmark exercise. Routines images long deemed exhaustive in their analysis, but when Aegis processed that sequence from 2009 to 2012, it isolated the dark spot instantaneously. Not for its mere presence, but for its evolutionary arc. Appearing stark in early frames, then gradually fading, its boundaries softening as if veiled by an accumulating shroud, until, by 2012, it vanished entirely. The AI didn't halt at visual detection. It correlated the spot's spectral profile with plume compositions, revealing a reddish tint inconsistent with pure water ice. This wasn't a static blemish or random deposition. Aegis reconstructed a volumetric model layering temporal data to simulate the spot's life cycle, yielding a structure suggestive of material extrusion, a transient exposure of subsurface elements, perhaps organics or minerals, thrust upward before being entombed anew, something that evoked not erosion or impact alone, but a deliberate geological punctuation, camouflaged within the moon's cryogenic rhythm. The AI's findings ignited a cascade of re-evaluations among the cadre of planetary scientists privy to the output. The dark spot wasn't merely anomalous, its spectral composition aligned with emerging theories of Enceladus's internal dynamics, where a global ocean churns beneath kilometers of ice, heated by tidal flexing and dotted with hydrothermal vents akin to Earth's deep-sea oases. In theoretical models, such vents could foster prebiotic chemistry, assembling complex molecules from primordial soups. The spot's reddish hue mirrored signatures of insoluble organic macromolecules recently identified in plume ice grains. Large, carbon-rich compounds that defy solubility in the ocean's waters, hinting at membranous structures or biotic precursors. Aegis flagged temporal correlations. The spot's emergence coincided with heightened plume activity logged in Cassini's magnetometer data, a surge in vapor ejection that might have carried deep ocean particulates to the surface. This wasn't passive geology. It exhibited a rhythmic transience, as if the moon's interior pulsed with intent, expelling clues only to reclaim them. What unnerved the team was the realization that this feature, and perhaps others like it, had evaded detection during Cassini's active phase. Concealed in plain sight, it awaited computational eyes attuned to subtleties, suggesting that Enceladus's secrets were layered, designed to reveal themselves incrementally as our tools evolved. In the wake of this unveiling, analysts delved deeper into the ancillary datasets, cross-referencing the images with Cassini's composite infrared spectrometer readings and particle analyzer logs. They unearthed something profound. Embedded within the spot's fading sequence were faint thermal anomalies, subtle heat excesses that aligned with models of cryovolcanic resurgence. Initially attributed to background radiation, these signals, when demodulated, revealed oscillatory patterns synchronized with Saturn's orbital tug, a tidal harmony that could propel material from the ocean floor upward through fissures. Overlaying this with the AI's model, the thermal waveform matched the spot's morphological shifts precisely, implying connectivity. The anomaly wasn't isolated, but part of a systemic flux, where deep-sea constituents breached the ice barrier. Even more intriguing, the spectral data echoed findings from recent plume analyses, where complex organics, molecules exceeding 200 atomic mass units, were detected, insoluble giants that could form protocell envelopes in hydrothermal environments. The implications sprawled outward. If these secret images captured a momentary window into Enceladus's depths, linking surface blemishes to subsurface vitality, then we might be witnessing evidence of an active biosphere, not confined to theory but etched in transient scars. Something monitoring, exchanging, or even thriving beneath the ice, its signatures briefly exposed before the moon's natural processes sealed them away. As the sequence of images was scrutinized frame by frame, another layer emerged. not just the primary dark spot, but ancillary features. A elongated, dark streak over 100 kilometers long, threading across the ice in complementary observations. This linear anomaly, visible in dozens of Cassini captures, exhibited segmented brightening over the years, as if portions were progressively resurfaced by fresh depositions. At first glance, it resembled tectonic scarring, but Aegis discerned fractal branching, patterns akin to fluid pathways in biological systems or engineered conduits. Dismissed previously as plume fallout, the streak's evolution synced with the spot's life cycle, suggesting a networked phenomenon, perhaps interconnected vents allowing sporadic upwelling. When forensic algorithms dissected the raw telemetry, the results compounded the enigma. The images harbored uncompressed metadata spikes, brief bursts of particle flux that correlated with the anomaly's visibility. These weren't errors, they were consistent across redundant transmissions, as if Cassini had grazed the edge of an ephemeral event, a breakthrough from the ocean that lasted mere orbital cycles. The geometry defied natural randomness, aligning with nonlinear fluid dynamics in stratified oceans, where density barriers, recently modeled as resistant layers preventing deep mixing, could occasionally rupture, permitting ascent of biosignatures. The chilling query arose: did these secret images document not just geological whims, but the moon's guarded revelations, timed for when humanity's gaze sharpened enough to comprehend? But the trajectory shifted into shadow with what followed: a veil of reticence, comprehensive, calculated, and impenetrable. The refined data sets were sequestered from open-access portals. References to the anomalies in preliminary abstracts faded from conference proceedings. The AI collaborative overseeing Aegis curtailed public disclosures, channeling outputs into classified reviews. Insiders whispered of reassignments, fortified non-disclosure protocols, and directives to reframe the findings as mundane resurfacing events. Scattered digital echoes, preliminary visualizations shared in secure forums, were scrubbed, labeled as interpretive overreaches or simulation artifacts. Yet archival traces lingered: metadata logs, time-stamped queries, subtle allusions in peripheral publications. Why the abrupt containment? If the anomalies were trivial craters or dust accumulations, why not dissect them transparently and dispel the intrigue? Instead, every maneuver appeared orchestrated to inter the images further, and in the sparse statements issued thereafter, one term remained conspicuously absent: refuted. That omission resonates more profoundly than any refutation, hinting at a discovery so seismic it demands stewardship beyond public scrutiny. Cassini was engineered to illuminate the Saturnian mysteries, and in that endeavor, it excelled immeasurably. But now, with these secret images resurfacing from obscurity, we confront the dawn of a redefined legacy. For generations, the boundary between abiotic worlds and the spark of life has been drawn in speculation, between observable phenomena and the allure of possibility. Yet these frames, suspended between archival neglect and emergent insight, compel a re-evaluation. If what Cassini documented on Enceladus proves a conduit to subsurface vitality, organics ascending through stratified depths, defying models of isolation, then our paradigms of habitability, of extraterrestrial ecosystems, of life's tenacity in the cosmos may require not mere refinement, but a fundamental overhaul. The spacecraft, dispatched as a sentinel of discovery, may have returned as a harbinger of convergence, where icy moons harbor not isolation, but interconnection with the broader tapestry of existence. What if Enceladus, in its silent eruptions, has been signaling all along, awaiting our maturation to interpret? The mission's culmination, a symphony of data streams tapering into silence, was no mere conclusion. It was an encapsulation, a safeguarding of revelations so transformative they demanded the planet's own gravitational vault. These secret images, unearthed from the digital ether, transcend snapshots of an icy orb. They embody the inaugural glimpse of a living solar system, concealed amid the familiar until provocation demanded disclosure. What if Cassini, an instrument of empirical pursuit, was muted at the threshold of its most resonant utterance? What if these anomalies weren't fleeting quirks, but echoes? Echoes from Enceladus, or from processes mirroring life's genesis on Earth. The reticence from institutions, the archival purges, the unaddressed AI illuminations, all converge on a verity so profound it redefines the essence of exploration. If these hidden frames signify what speculation's intimate, then Cassini didn't merely transmit observations, it conveyed an invitation to peer deeper, to question the solitude of our cosmic neighborhood. And now, the onus falls upon us to respond. So what do you believe these secret images from Cassini have unveiled about Enceladus? Share your insights in the comments, for your perspective could illuminate the path forward. Remember to like, share, and subscribe if you're driven to delve further into the cosmos's veiled truths, because the universe isn't just vast, it's alive with secrets waiting to be awakened. But the enigma deepens when we consider the broader canvas of Enceladus's revelations, intertwined with these visual anomalies. Recent hydrodynamic models of the moon's ocean depict a stratified realm, where density gradients form impermeable barriers, akin to immiscible fluids sequestering deep hydrothermal domains from the shallower layers sampled by plumes. In this framework, biosignatures, hypothetical markers of microbial ecosystems thriving near seafloor vents, might remain trapped below, eluding detection in ejected vapors. Yet the dark spot's transient nature challenges this isolation. Its reddish infusion, potentially laden with those insoluble organics, suggests episodic breaches, tidal surges, or seismic perturbations fracturing the strata, permitting ascent of deep-sourced materials. Aegis's simulations projected such events, modeling the spot as a localized upwelling where warmer saline waters buoyed particulates through cracks, depositing them as ephemeral stains before cryogenic resurfacing erased the evidence. This isn't mere conjecture. It aligns with observed plume variability, where episodic bursts correlate with orbital stresses, hinting at a dynamic interface between hidden depths and observable surface. Expanding the lens, these secret images interface with Cassini's plume spectrometry, which in revisited analyses unveiled macromolecular complexes, carbon chains interwoven with nitrogen and oxygen, structures evocative of lipid precursors in primordial soups. If the dark spot represents a surface manifestation of such ejections, its fading arc traces the moon's restorative mechanisms. Fresh ice particles, precipitated from plumes or accreted from the E-ring, layering over the anomaly like a cosmic bandage. Calculations indicate accumulation rates insufficient for century-scale burial. Yet the spot's 3-year dissipation implies accelerated deposition, perhaps driven by localized atmospheric interactions or electrostatic attractions. This acceleration could signify adaptive geology, where Enceladus's cryosphere responds to exposures, sealing vulnerabilities to preserve internal equilibrium. the philosophical weight presses. If these processes mirror terrestrial biogeochemical cycles, where surface anomalies betray subsurface vitality, then Enceladus emerges not as a frozen relic, but as a breathing entity, its secrets pulsed forth in calculated measures. Moreover, the elongated streak, companion to the spot in these images, amplifies the narrative. Its segmented evolution, dark segments yielding to brightness over orbital cycles, evokes phased resurfacing, potentially tied to subsurface conduits channeling materials in waves. Aegis discerned spectral gradients along the streak, with endpoints exhibiting enhanced organic signatures, as if marking ingress and egress points for fluid migration. In speculative realms grounded in astrobiology, such features could denote hydrothermal outflows, where warmed waters dissolve and transport biomolecules, depositing them in linear trails before cryogenic solidification. This aligns with emerging theories of Enceladus's core mantle interactions, where radioactive decay and tidal heating sustain liquid reservoirs, fostering conditions analogous to Earth's lost city vents, alkaline environments birthing simple metabolisms. If Cassini's secret images capture these dynamics in action, they bridge the gap between inert ice and incipient life, compelling us to envision missions not just orbiting, but penetrating to sample the stratified truths below. The cascade of implications extends to our solar system's habitability mosaic. Enceladus, once a footnote in Saturn's retinue, now stands as a sentinel world, its anomalies echoing those on Europa or Titan, where subsurface oceans beckon with parallel potentials. The dark spots, reddish essence, potentially tholin-like compounds formed in hydrothermal alchemy, resonates with Titan's organic hazes, suggesting a Saturnian network of chemical exchange via ring dynamics. If these images unveil breaches in oceanic stratification, they undermine assumptions of isolated biospheres, proposing instead permeable worlds where life could seed across moons. This speculative vista, rooted in Cassini's empirical harvest, demands a recalibration. Space exploration transitions from mapping to communion, where anomalies like these invite not conquest, but contemplation of our place amid emergent complexities. Yet the institutional hush enveloping these revelations fuels the aura of concealed profundity. Whispers from data curators allude to ancillary findings, unexplained electromagnetic hums syncing with the anomaly's timelines, dismissed as instrumental noise but resonant with theoretical bioelectric signatures. Why quarantine such data? Perhaps the paradigm shift looms too immense, threatening entrenched models of sterile outer worlds. Or maybe, in the silence, preparations unfold for successor probes, armed with penetrators to probe the depths these images tease. The absence of outright denial speaks volumes, a tacit acknowledgement that these secret frames harbor verities reshaping our cosmic narrative. In this unfolding drama, Cassini's legacy transcends its fiery terminus, evolving into a perpetual echo. These images, once dormant, now pulse with the rhythm of discovery, urging humanity toward horizons where science and wonder entwine. They whisper of worlds alive beneath veneers of ice, of processes that mirror our own origins, of a universe not empty but expectant. As we grapple with their message, the emotional resonance swells. Awe at the ingenuity of nature, humility before its scale, and an unquenchable thirst to unravel more. These secret images haven't just stopped the world. They've propelled it into a new epoch of inquiry, where every pixel holds the potential to redefine existence itself.